Do you recall in our previous lecture, I told you that logarithms are inverse of exponents. So today we learn how actually we solve logarithms. Here you can see how we write exponents. 2 to the power 3 is equal to 8. So here we have written the exponential form, that is a to the power n is equal to b. Now how do we write the inverse of this? If I say that logarithms are inverse of exponents and these are exponents, how do I write logarithm? Well, let me show you. You know that log of 8 is equal to 3 when the base is 2. Right? This I have already told you. Now, similarly, if a to the power n is equal to b, then the log of b is equal to n when the base is a. Right? But do we write like this? Such a big thing? Such a big statement for logarithm? No. How do we write this? We write log 8 is equal to 3, and instead of writing when the base is 2 in the bracket, we write 2 here, like the base of 2. So log 8 to the base 2 is equal to 3. Similarly, here what we will do? Log b to the base a is equal to n. So this is how we express such exponential functions in logarithm. Look, log 8 with the base 2 is equal to 3. So if you are given this, that means 2 to the power 3 gives you 8. So log of 8 when the base is 2 is equal to 3. So what do you understand? We understand that 2 when multiplied with itself 3 times give you 8. Similarly, if I say log b to the base a is equal to n, then you understand that a when multiplied with itself n number of times give you b. Now, how do we remember that? That 2 multiplied with itself 3 times give you 8? Well, that is very easy. But how will you remember that always we have to take the base first, then this will be the power and this will be the answer? Well, just take the opposite arrow like this. So it will always go from here to here. So 2 to the power 3 gives you 8 and a to the power n gives you b. So always take it like this. Say log a, like log b to the base a gives you n. So always take the arrow from here to here. So this will remain the base. You know that log b to the base a, so even in exponents, this will remain as the base. So base is the same in both logarithm and exponent. So base, then this becomes your power and this becomes your answer. So this is how we write logarithms from exponents. Now there are some conditions for a, b and n. Well, what are those conditions? Well, if a is any positive real number, so if I say that a to the power n is equal to b and n is called the log of b to the base a, then actually a should be any positive real number except 1. So if a is 1, then it does not hold. That is, the log does not hold. So always a should be any positive real number except 1 and n should be any rational number. So always remember this. Whenever we will do any calculation for log, we will always assume that a is any positive real number except 1 and n shall be any rational number. And if a to the power n is equal to b, then and only then, or you can say if and only if a to the power n is equal to b, then n is called the log of b to the base a. So thus a to the power n is equal to b if and only if log b to the base a is equal to n. Do you notice the similarity? Both the places a is the base, a to the power n is equal to b only if log b to the base a is equal to n. Well, that is simple. You know that we have written this form from this only. So both has to be same. Now you can see that this is the exponential function and from this only we have derived this, which is the logarithmic form. So this is the exponential form and this is the logarithmic form. So you need to know how to convert the exponential form to the logarithmic form and the logarithmic form to the exponential form. Let's do a quick exercise. Well, you can see 4 to the power 2, that is 4 squared is 16. How will you write this in the logarithmic form? Just now I have told you, write it down. Well, I told you that the base remains the same 4. So what we will do, we will write log. We will write the base 4, right? And 16 comes here and the answer goes 2. So remember that arrow thing I told you? It starts from here to here. So 4 to the power 2 gives you 16. So log of 16, that is 16 can be expressed as 4 multiplied with itself 2 times. Similarly, 5 to the power 3 is 125. We have already done this example, so you may be remembering this. Write the logarithmic form of this exponential form. Well, log of 125 is equal to 3. Well, do you agree with me? Have I written the right thing? Well, no? Why? Well, I have written log of 125. I have written the correct answer also 3. But what about the base? I have forgotten to write the base. Well, do not do this. Well, do not forget to write the base at any time. It is very, very important, because then only you will know which number needs to be multiplied 3 times with itself to get 125. So, you do not write logs without bases like this. Well, logs written without bases have some different meaning. I will tell you about that later, but now you remember that do not forget to write the base. Next, again, do this. We have given you the exponential form. Write the logarithmic form for it. Well, log of 0.001. What will be the base? The base will be 10 is equal to minus 3. So this is how you convert exponential form to logarithmic form. Now you should know the opposite also. You should know how to write the exponential form from the logarithmic form. So now we will do that. I have told you, take the arrow. So 8, when multiplied with itself, 5 by 3 times. So it will come 5 by 3 on the power, gives you 32. So you can see how when 32 is actually not divisible by 8, but still it can be expressed as 8 when multiplied with itself 5 by 3 times. So this is how logarithm helps. Logarithm changes any number in short numbers, like how any number can be expressed by a certain number when multiplied with itself a certain number of times. And this is called the base. Similarly, write this. You know that the base remains the same in both logarithms and exponents. How will you write the exponential function of this? Take the base a, when multiplied with itself minus 1 times, give you 1 by a. Right? Again, we have log 0.001 to the base 10 gives you minus 3. Now, we had just done this kind of example when we were doing the opposite. So, do this. Write the exponential form of this logarithmic form. The base remains the same. Now, 10 to the power minus 3 gives you 0.001. This is how you change logarithmic form to exponential form. Now, till now, you have learned how to change logarithmic form to exponential form and vice versa. Now, do you know exponents also help in solving logarithms? Let's see how. Now, suppose I do not know the answer of this log. The log of 16 to the base 2 is unknown, and you need to find out this. How will you do that? See, let us take log of 16 when the base is 2 is equal to x. Then what will happen? We can convert this logarithmic form to exponent form. You know that? So the base remains the same. To 2 to the power x is equal to 16. Right? Now tell me, what can be the value of x? How many times 2 needs to be multiplied to itself to get 16? 4 times. So you can say that 2 to the power x is equal to 2 to the power 4. So what is the value of x? X's value is 4. So we found out that log of 16 when the base is 2 is actually 4. So this is how you solve logarithms. Solve this. Tell me what can be the answer. Well, again, we will take this missing number as x. So 5, like log 0.008 to the base 5 is equal to x, because this is unknown. We have taken this as x. Similarly, like in the previous case we did, to convert this logarithmic form to exponential form. So 5, the base remains the same, to the power x gives you 0.008. Well, you may be thinking, now how to solve this? 8 is not a multiple of 5. It does not come in the table of 5. How will you do this? Well, convert this decimal into fraction and see if it helps you. Well, 5 to the power x is equal to 8 by 1000. I've converted the decimal to fraction. Now cancel this out. What will you get? You get 5 to the power x is equal to 1 by 125. Now this seems easy. 125 is a multiple of 5. How will you do this now? Find out the value of x. Well, 5 to the power x is actually 5 to the power minus 3 here. You know why I have put minus 3? Because this is 1 by 125. So, what is the value of x? X's value is minus 3. So, the log of 0.008 to the base 5 is actually minus 3. You get it? So this is the basic version of log. This is how you do exponential form to logarithmic form and logarithmic form to exponential form, and also solve logarithms.